An RDBMS includes normalized tables managed in the relational model. A normalized table is a table where the redundancy is taken out to make the data storage and access more efficient. And so on the left there, you see a flat file, just a standard table, which has employees listed by office, city, and zip. And you can see there's a lot of redundancy in that flat file. For example, Alvarez, Army, and Smith are all officed in the service office in Plano in the zip code 75024. And so if the office moves, for example, to a new zip code, I have to update the zip code in 3 different records. That's not very efficient. In a relational table, you split out the repetitive data, in this case, the office, city, and zip, into its own table, and then relate that back to the employees. And so if I have to update or change the service office from Plano and the zip code to another city and zip code, I can just change one record and it will replicate back to all the employees that are stored there. In this case, we're only talking about 3 employees, but what if you have 3,000 employees? Then you only have to change one record to update the data for 3,000 employees. That's a much more efficient way to store and manage data. So the process in normalization is to organize columns and tables to reduce data redundancy. And we do it by decomposing a table with redundant values into a more efficient set of related tables. The advantages of this are not only reducing data redundancy, but it improves data integrity. I only have to edit one record instead of 3,000 records, for example, and it allows for more flexible and scalable data. Here's an example of a denormalized table. This is a grocery store, for example, that manages a purchase order for groceries. And you can see that each order and customer is managed in each record of the table. And so Jones has the first 2 orders, one that has 3 items and a second one that has a single item, flowers. And for every item, there are 3 different attributes: the description of the item, the quantity of the item, and the price of the item. Now, the problem with this table is most people, when they go to the grocery store, don't just order 3 items. Some order 5 items, some order 50 items, some order 150 items. And so with a denormalized table, you have to anticipate what the largest order is going to be, let's say 300 items, and then you have to store those values for every single customer, not just the customer that's ordering 300 items. And so it's a very inefficient way to store data. When we normalize data, we organize the tables by topic and relate them by a common field. So in the example of the purchase order table, we're going to organize the data by purchase order and then by purchase order item. So we're splitting that data out into 2 separate tables and relating them with a common ID. In this case, the order number is the primary key, and the order number that is stored in the purchase order item table is the foreign key. And we have a many-to-one relationship from the purchase order items where there are many items to one purchase order. And so this process of removing repetition by creating a one-to-many relationship is called the first normal form. The second normal form is when we separate static from dynamic information by creating many-to-one relationships. So in our first normal form table that's on the left, we see we have the purchase order table and the purchase order item table that are related by the order number. But some of this data is pretty static. For example, the customer information might not change for years, so that we can split that data out in the second normal form. And now we have 3 different tables. We have the purchase order item, and now we have the customer table. And so the customer table is pretty static and doesn't change as much. So we don't have to really get into that table very often. It's the purchase order and the purchase order item table where we're going to see a lot of transactions. The third normal form is when we resolve many-to-many relationships into unique values. We do this because a many-to-many relationship is very complex. For example, on the left, you can see there are many courses to many students, meaning that I can have a single course with many students, and I can have a single student that's in many courses. And so in the third normal form, we resolve this relationship out from a many-to-many to a one-to-many, which makes it just a little bit easier to manage. And so we create an index table of course and student IDs in which we can establish a one-to-many relationship from the course to the course student table and from the student to the course student table. In addition to the third normal form, there's the fourth, the fifth, and the sixth normal form, but it gets pretty abstract at some point and is really the domain of a database administrator.